The topic for 10.2 is angles and triangles. Angles come in different classifications. An acute angle is an angle that measures less than 90 degrees. This is being an example of an acute angle. 60 degrees, roughly, that's less than 90. Anything less than 90 is an acute angle. A right angle is an angle that measures 90 degrees. One way to define that or to demonstrate that is something, a ray that goes straight up and a ray that goes straight out, and that would be 90 degrees. Another way is to take a circle and take the midpoint of the circle. Our distance around, when you go around a circle, it's 360 degrees. So if you split that circle into 4 sections, you divide 360 by 4, and you get 90. So each of these would be 90-degree angles. An obtuse angle is an angle that's greater than 90 but less than 180. So if I take these two rays and just move this one around a little bit and make it about right there being a 180-degree angle, that's not obtuse because it's not less than 180. But as soon as I close that angle up and make it a little smaller, that would be an obtuse angle, and I can just slide it all the way up here. It's still obtuse, 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 until it gets to be, it's still obtuse, probably looking like obtuse. But once I get to 90 degrees, that's a right angle, not obtuse. And if I go over a little further, it becomes an acute angle. So obtuse angles are between 90, but not 90. So as I move off of the 90-degree angle, like 95 degrees, 100 degrees, 110 example, all the way to 179 degrees, that's an obtuse angle. A straight angle measures 180 degrees. So if I have a line and I create a vertex, and I'll just name a couple points here. I'll call this point B, and this point A, and point C. So if I go from A through B, here's my ray BA, and then ray BC together make an angle, and it measures 180 degrees, and we classify it as a straight angle. Two angles are complementary when their measures together add up to 90 degrees. So the green angle and the white angle, the green angle being 40 and the white angle being 50, they obviously make 90 degrees. And when you put them together, well, I'm not sure why the 40 is spinning, but just disregard that one. We get a right angle. I'll go ahead and draw that 40 back in there where it belongs. So 40 plus 50 gives us 90. And we can see it kind of together makes the right angle. So complementary angles, the measures add up to 90 degrees. Angles are supplementary when their measures add up to 180 degrees. So we take the green angle and put it next to the white angle. And if it makes a straight angle together, which it appears to be close to, just imagine that it does, then those two angles are supplementary to each other. Their measurements could be, like if this was 40 degrees, we would know this would have to be 140, because 40 degrees plus 140 gives us 180. So another way to put it is that if you put the angles together, they would make a straight angle. Supplementary angles measures add up to 180 degrees. Adjacent angles are two angles that have a common vertex and a common side, but no common interior points. A couple of words to make sure we understand. Common means shared, and interior means inside. So if I draw an angle here, and this is the vertex, if I draw another angle with the same vertex and another ray going this way, which would share the green ray. So they have, the blue-green is the common ray, common side, and we'll call this point B. Point B is the common vertex, but all the points inside the blue do not intersect or overlap with anything inside the green angle. So they have no common interior points, which makes them adjacent angles. The interior angles of a triangle are the inside angles of a triangle. So we see the red is an interior angle, the white angle is an interior angle, and the blue angle is an interior angle. Now something special is this theorem about these angles. If I pull them apart and turn them in certain ways, and put them together, always the same thing happens. the red, the white, and the blue, the three interior angles of the triangle. We'll call the red angle A, just kind of go with it, angle A, plus let the white be angle B, plus the other angle, angle C, always adds up to 180 degrees. So if you take the interior angles of a triangle and add them together, the measures of their angles, you will always get 180 degrees. In your book it says, the sum of the measures of the angles in a triangle is 180 degrees. It's always true. So if you knew this red angle was, say, 40 degrees, and the white angle was 90 degrees, but you don't know the blue angle, you can say 40 plus 90 degrees gives me 130 degrees. And then the missing part would be whatever I have to add to 130 to get 180. So I can subtract 130 from both sides of this and figure out that that missing angle must be 50 degrees. Exterior angles of a triangle are outside the triangle, and they're formed by extending the sides of the triangle. So the red angle, designated as angle 1, is an exterior angle. Angle 2, the blue angle, is an exterior angle. And angle 3, the green angle, is an exterior angle. And the special thing about exterior angles is if I add them up, if I do angle 1 plus angle 2 plus angle 3, we always get 360 degrees. I'm not going to demonstrate that. It would be kind of easy to do. But you all would just take the theorem that the red, the blue, and the green always add up to 360 degrees.